Alright, so we got in a real big mess in that last question, and it was tough because you needed to know about SIRS, you needed to understand what you're doing with your fraction work. A lot of these things, when it comes down to it, although you think, yeah, I've nailed fractions, fractions are easy, what's a half plus a half, and things like that, but in order to keep these sort of ratios the same, you really need to know fundamentally what you're doing, and sometimes you just have to go all the way back to the beginning, using numbers as I did, and what I've done there, I'm rusty, okay? The answer's in front of me, but only the answer, I haven't got the working out. So, I have to apply, logic to work independently. I haven't got a maths tutor here, a teacher to ask, how I can work this out. I have to use my own brain and just sort of demonstrated to you how it's possible to use your own brain to work out things, and you get used to doing that. And plugging in numbers is always a good way of testing out whether something works or not. So, okay, let's do the next question, and hopefully we'll ram through it because they are getting tougher. They're definitely getting tougher. That was a toughie. That asks for a lot of information. So let's see what this triangle, this beauty, has in store for us. So it looks easy so far, but then it's split into two triangles like so, and it wants us to find this length here. And we've got 13 centimeters. This is 30 degrees, and it gives us that that's the right angle, or a right angle. That's 45. So that's an isosceles triangle. Okay, 45, 90, 45, and this triangle here. Well, this is going to be quite an interesting one. I'm looking at this and thinking which way to go about it. We've got this information, and this is our information, and this triangle here. People might go for this one, but it's not a right angle. So this is a red herring. Don't get caught out by this. Let's use the whole entire triangle to find this side here. I don't want to find this side because this is, if I find this side, then I've still got this, and it makes it ever more complicated to find that. So we're going to find this side first, and we're going to change colours. Part of sort of watching me do these questions is to enable you to kind of to teach you how to approach a question, and this might dazzle a lot of people, and it would dazzle me if I hadn't practiced. And yes, it does take a bit of practice to see what you're doing from the outside. So anyway, let's go for it. So we've got the opposite, and what length is that? It's opposite a right angle, and you see that's why they've included the right angle, because it's giving you a clue. It's giving you, it didn't. Yeah, it's giving you a clue. You're supposed to see that perhaps, and think, oh, okay, I might have to do something with that. So we've got a right angle, and we know it's hypotenuse, so we're using sine. Okay, quite like using sine. We've used that quite a lot, and we're going to use sine 30. So can you think already what sine 30 is? What was our opposite? So we'll make that up, and we know our hypotenuse. So what was sine 30? It is a half. So this should be quite straightforward. Won't skip any steps. So the opposite is then 13 over 2. Good. So we know. Let's fill that little detail in. 13 over 2, and see what we can actually do with that. We want to find x. So we haven't got the opposite. We want to find the hypotenuse, and we want to find the adjacent. Let's do it in a different colour. So we'll find the adjacent hypotenuse. Well, that is completely wrong, isn't it? Tar. Right, Dokatawa. So we've got cos 45. Look quite tricky actually to begin with, but actually it could be straightforward, but depends what's going to happen now. So what do we have? Adjacent was the 13/2. Hypotenuse was x. And now we need to remember what cos 45 was. So cos 45, and this is quite good because cos 45 and sin 45 are the same. So we've been working a lot with sin 45, which remember is this. And now again it's going to get quite sticky and messy, but I think we've seen calculations like this already, so we should be able to manage to do this. But let's not skip any steps. Let's try and get this answer right first time. That's the idea. That's what we want. And it would just be a case of checking our answers rather than actually checking for the mistake in our answers. And right, that's a 2. So we've got 26 over and that brings us to that whole problem that we had in the last question, but we solved that. We managed to prove to ourselves that we can actually, quite simply, to get that square root 2 on the top, we can just simply times the square root and not the 2 as well, because if we have to times the 2 as well, then it's just going to add another sort of calculation, and mathematicians like to make it as easy as they can for themselves. So that means we're going to have 26 times the square root of 2, and on the bottom we're going to have the square root of 2 times the square root of 2, which is 2 times 4, times 2, which is 4, and then it's just a case of finding the highest common factor, which would be 4 in this case, and that'll be, so you've got 4, that's not 13. No, the highest factor is 2, sorry, that's why it's 13. I was thinking ahead of myself there. And that should be the answer, so I'm just going to check that now. That was question 13, and yes, it's the right answer. So, viewers, you can be certain. I give you my absolute certainty that this is all correct. And from doing the previous question, we were able to do this question in pretty quick time. And we've got one monster of a question next, so it's the climax, it's the final question, and I really advise you to be there because it's the grand crescendo, the finale of this particular exercise. See you in the next video.